Today's lecture on optics is going to involve different types of materials and how light behaves when it interacts. So a lot of what we'll talk about is reflection and seeing the objects that reflect light. We're going to be drawing normal, in this case, ray diagrams where we have to make sure we establish what the surface is. Generally, we'll talk about a mirror or shiny surface. We talk incident rays and reflected rays, and obviously the normal line. So here's some pictures. First things first, we've got to talk about characteristics of materials. Light responds differently to different materials. A transparent object is going to allow for light to be transmitted or passed through so that details of the object can be seen with distinct characteristics. Something that's translucent allows light to be passed through but with little detail. So you're actually going to be you're going to be getting some distortion of what is over on this side. You can still see through it, but you can't necessarily see the detail. And something that's opaque. Light is unable to be transmitted and thus reflects, in this case diffuse, from its surface. You are an opaque object, and therefore your shadow is simply not allowing light to reach this area. So light is going to reflect off of you, and your shadow is simply the void or lack of light. So here's an example of transparent, translucent, and opaque. So transparent, we can see through it. We see this round sphere here. Something that's translucent, well, we can still see through it, but it's a little murkier. And last but not least, opaque. We know it's there. We can actually even see its shadow here. But we can't see the object itself directly through an opaque object, so it's blocking light altogether. So transmits it completely, transmits it somewhat, and does not transmit at all. Instead, reflects off an opaque surface. So seeing objects, light and color that are reflected. So let's look at this apple for a second. There's a couple things going on. So why do we see the apple as red? Well, we just apply the subtractive color process of white light that is shining on the apple allows us to see both specular, the white dot, and diffuse reflection, why the apple is red itself. So the white dot is where the wax coating of the apple reflects all the colors of light, additive color process. So the white dot is specular. All of those of the light that's shining on the apple itself, that's light. We combine those together and we get white. But we see the apple is red as light reflects off the uneven surface of the apple, and that's a subtractive color process. So here's a further illustration. White light coming in, white light reflecting off. Boom. There's your kind of a mirror of sorts. Diffuse, we see it as red because of the colors that are reflecting off it is only red that's going to be absorbing its complement. In this case, we're talking about the reds and greens are going to be absorbed. But light can do several things at one time. If we have white light shining on this material here, if we call this plastic, for example, even though it might be transparent, light is still going to reflect at this boundary. It's a surface. It's an interface of two different media. We can call this air, we can call this plastic. Some of it's going to reflect, and some of it's going to be transmitted. But notice of the transmitted light, it's actually going to refract also because of the change of media. They have different index of refraction. So the laser lab, when we shine a light or laser into a transparent material, some of that light energy is reflected at the boundary between the air and the glass or water or plastic, whatever the material is, it doesn't matter. While some of the light is transmitted, passes through, as it refracts due to the different refractive index of the media. So we're considering multiple things at once. But the law of reflection comes into play every time and any time we're looking at light reflecting off a surface. We're talking about the angle of incidence. That's going to be your interior angle here, your angle of reflection. The law of reflection simply says that the angle of incidence equals the angle of reflection. And this applies to any surface with specular reflection. So here are the key terms we've looked at in the past. I just want to make sure we understand rays. There's an incident, incoming, and reflected, bouncing off. We have our normal line, we have our angles, and we have our surface. So just a kind of a review there. So looking at this ray diagram here, I know it's review, but I just want to make sure we get this. Normal line, the incident ray, and reflected ray. I know I've gone over this several times, but I've got this picture here. It's just showing you. Incoming white light is going to reflect off the surface. It's going to be reflected as white light as well. So let's talk specular reflection. Reflection is simply bouncing off, or bouncing off of. A ray that strikes a shiny surface, like a mirror, creates a single reflected ray. So here we can imagine a ball that comes in at an angle. It's going to bounce off at that same angle. Well, so does light. Light is going to reflect off of, this case, all the light in a specular, in this case a polished material like that of a mirror. Each ray of light bounces off in a single direction. So if there's a whole bunch of light coming in, there's a whole bunch of light reflecting off. Diffuse reflection is a little different. Opaque objects have uneven surfaces that scatter incoming light, and as a result we see the surface of the material. Light is reflected in many different directions, simultaneously, all at the same time. So comparing in this case specular, to diffuse reflection, we're seeing a whole different set of events that take place with the photons. Here, all of them are reflecting off. Here, they're deflecting off in different directions. Here, we can apply the angle of reflection, or the law of reflection, excuse me. And here, we're really looking at diffuse reflection. They're moving when all the beams reflect at many different angles. You can't see a reflection because not all the reflected light is detected by your eyes. The light that is detected by your eyes allows you to see the surface. Here, we can see the surface. Here, we cannot. So let's look at this picture for a second. And this is a diagram from our text. Picture A. An opaque object reflects light in many different directions, called diffuse reflection. In this case, we can actually see its surface, right, of paper. We can see the surface of paper. But the mirror, picture B, is that polished surfaces reflect all the light. This is specular reflection. We cannot see the surface itself because of all the light that's making it to our eyes. We simply see what it's reflecting. So here's a good picture that kind of puts it all together. Reflected light, this is a mirror. This is where we apply the law of reflection. So here we're looking at specular reflection. It bounces back in the same direction it was coming from. And here we have diffuse reflection. It's scattering the light in different directions. So in summary, we're looking at how light is going to respond to different materials, and that's going to depend on if they're transparent, translucent, and opaque. Generally transparent and translucent, you're going to get some form of reflection off the material, but it's going to be a little different. Opaque is going to, in this case, diffusely reflect light, whereas when we talk about something that is going to travel into a different media, it's going to reflect light a little bit differently. So it's going to reflect light and it's going to refract light while being transmitted. So a lot going on.